Hey YouTube, today I wanted to cover rapid spanning tree and multiple spanning tree. So rapid spanning tree is the newer version of spanning tree that speeds up convergence times compared to regular spanning tree. So instead of having that 15-second listening and learning state, the default now is 2 seconds. Also, rapid spanning tree drops the listening state in favor of just the learning state. And it also uses a new feature called topology change notification, TCN, which it does what the name sounds like. It sends out topology changes throughout the switched environment. So these changes have sped up convergence times to 1 to 2 seconds instead of the traditional 30 to 50 seconds of standard spanning tree. So to enable rapid spanning tree, we go into global configuration mode and type in spanning tree mode rapid PVST. And that's it. We have now configured rapid spanning tree. To verify, we can do the show spanning tree summary. And here we can see the switch is in rapid PVST mode. Now with standard spanning tree, we need to tell rapid spanning tree what ports are at the edge. So the ports that the endpoints connect to. Again, we do this in global configuration mode. We're going to use the portfast command that we've discussed in previous videos. Now we can also do this at the interface level by doing spanning tree portfast, but I'm not going to do that at this point. So now we can verify that our ports are now edge ports by using show spanning tree, and we can see they're now saying edge. Now all the other commands, like I said, that we discussed in previous video about enhanced spanning tree, a lot of those are still available, such as BPDU guard, and it's the same configurations as the previous ones. So that's really the fast and dirty of rapid spanning tree. So now I'd like to turn our attention towards multiple spanning tree. Now multiple spanning tree, like rapid spanning tree, has fast conversion times. The difference is that with multiple spanning tree, you create the instances of spanning tree. Now if you noticed in Cisco's implementation of spanning tree and rapid spanning tree, they say PVST, or per VLAN spanning tree, in front of it. This means that every single VLAN you create on a switch will have its own instance of spanning tree, which if you have a lot of VLANs created on your switch, you are going to be using more memory and more processing power. And then with multiple spanning tree, you can create the amount of instances you want and just assign the VLANs to them. So the first thing that needs to be done to configure multiple spanning tree is we have to set up some of the basic configurations. Now, what do I mean by that? The basic configurations are the mapping of the VLANs to an instance, a name for the instance, and then a revision number. So these are all required to set up MST. If you don't have this configured and you type the command to switch to MST, it just won't work. So the first thing we have to do is do this basic configuration, and again, that is also in global configuration mode. We're going to type spanning tree MST configuration, and now we're in the MST subconfig mode. Now from this configuration, we're going to do our mapping, and the command for that is instance 1 VLAN and the VLANs you want to add. So in my case, I'll do 10 and 11, and then instance 2, we'll put in VLAN 20. Now we have to do this with, we also have to add our revision number. If I can type revision, I'll just call it revision 100. And then finally the name, and I'll just call it HQ VLANs. So that's it. Now we have the spanning tree MST, or the spanning tree configurations completed. So now we can actually turn on MST. And that command is spanning tree mode MST. And that now switched us to the spanning tree, multiple spanning tree. And we can verify that by using our trusty show spanning tree summary command. And here we can see switches in MST mode. And now all the other show commands that we've done with spanning tree all work. So we could also do just show spanning tree. And then we'll see, again, that we're in multiple spanning tree protocol, that this is the root, we're in a forwarding state, and these are edge ports. And you can see these are not edge ports, they're just said shared ports, and that's because these are trunks. So we're not going to, like I said in the video, our trunk ports will not become port fast edge ports, at least not by default. So now, one of the differences from the previous two spanning tree modes is how we set the root switches. Before, the root was set for the VLAN, since it was per VLAN spanning tree. However, with multiple spanning tree, we set the root based on the instance of spanning tree. So the command to set a switch to be the root for an instance is similar to before, but I'm going to do this on switch 2. It's in global configuration mode. We're going to do spanning tree, MST, the instance number, and I'll use my instance 1, and then we set the priority. So I'll set it to 4096. Now, we can also use that macro version that I mentioned again in the last video, spanning tree, MST, and the instance number again, to root primary. Now, this will then set the priority on the switch for me for that instance. Now, with multiple spanning tree, there is something called the common spanning tree instance. This is instance 0. I don't know if you saw that when I did the show spanning tree command, but that instance has any VLAN that hasn't been assigned to an instance already. So let's just do the show spanning tree again. Here you see MST 0. And really, the VLAN that's in here might be VLAN 1. That's the only one created. Otherwise, we have our MST1. The priority has changed, and it is now the root. And then MST2, the instance 2, the priority changed using the macro and became the root. So there's times you might not want to see all the instances. A handy command is the show spanning tree, MST, and then the instance number, so we'll just do 1. And then you only see, obviously, instance 1. And here it's nice because it also tells you what VLANs are mapped to it. So just to show you on 0, it's actually every other VLAN that I mentioned. So it's all of them. So these are the basic configurations for spanning tree. I'm not going into much detail on necessarily the operations of it, but just how to configure it. One thing to note with common spanning tree, that's common among the spanning tree modes, is that you're most likely in the real world just going to see rapid spanning tree. That configuration is easier. Multiple spanning tree, it's nice, and it's not terrible to configure, but that configuration has to be on every single switch, and it has to be correct if you want the instant mappings to not be off. And then also another little note with all these versions of spanning tree is they do have a fallback feature that will downgrade itself to the common standard spanning tree protocol. So if you're running rapid on one, standard on the other, the rapid one will downgrade itself to work with the standard spanning tree. So this covers the basics of spanning tree, how to mostly just to configure it, and a little bit on how it works. We're going to finally get off spanning tree and move on to a new topic, and that new topic in the next video will be VTP, or VLAN trunking protocol. Thanks everyone for sticking around.